Okay, so for next time in Shobi we got library functions, quiz due, 1.7 homework worksheet due in Shobi, and quiz finding domain due in Shobi. Show your work algebraically, and we'll go over how to do that as we cover section 1A. All right, and so here's 1.7. We're gonna talk about domain in section 1.7 here. This is combinations of functions, composite functions. So when we find a function's domain, if a function f does not model the data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So, you've got to have real numbers, whatever. So, the largest set of numbers here in this first example, and we could graph it and find its domain, but in this first example, you can put any number in for x from minus infinity to infinity, and you still get a real number. So this is just a slanted line. This is a straight line. Its domain is minus infinity to infinity. Okay? Now, so when we have to restrict the domain, something like this, a line that it starts at 21, and you go up 3 over 1, so it's just a line like that. If you project it to the x-axis, it can be all real numbers, but you don't have to graph it to figure that out. If you can put, there's no reason to restrict x here. No matter what you put in for x, you get a real number. As long as x is a real number, you get a real number for f of x. So, but the reason we want to restrict domains, if we have a square root of x function, we can't divide by a negative number. So the domain for this is that x has to be greater than or equal to 0. So, or we need to write that in interval notation, 0 to infinity. We never use square brackets on the infinities. That's an extra example. So when we have square roots, we need to make sure that the radicand, that's what's inside the radical function, is greater than or equal to 0. So on example B, because it's a square root, even power roots, you're going to have to make sure the inside of the root is greater than or equal to 0. Cube roots is okay, it can be negative numbers, fifth roots, things like that. But square roots, because you can't take the square root of a negative number, you have to make sure, so for this example, x minus 7 has to be greater than or equal to 0. So this is what I mean by showing your work algebraically. You're going to write x minus 7 greater than or equal to 0, then you're going to add the 7. You can add that in your head, that's fine, x greater than or equal to 7, or you could add 7 to both sides. And show your work that way. And so now you have to write that in interval notation, 7 square bracket, because it includes the 7, comma, infinity. And that's the answer. So you really just need to show 2 steps. But if you don't show those 2 steps, you're not going to get very much credit. So I know you can do that in your head, but it's because I can't read your mind. So I just want to see that algebraically. You can check that on your calculator too. You can look at the domain of this square root function in your calculator. You can find it with the calculator. Does anybody want to see that? Okay, so you can find it in the calculator, you plug this in and look at it under table, but you need to show these two steps, then you've shown your work algebraically. That's what that means. Okay, so if you're taking the square root, you need to make sure the inside of the square root is greater or equal to 0. And that's finding the domain. Alright, the next one, if you divide, if you have a fraction and you have x's in the denominator, so if you're dividing by a variable, I guess I'll just write it up here. If you're dividing by a variable, variable, okay, variable. Make sure that no denominators equal 0. The bottoms of the fractions. You can't divide by 0. So you have to restrict the domain to exclude the values that would make the denominator 0. So the next example, we're going to set the denominator to 0 and factor. Okay, and people are still copying that. So we can't divide by 0. So these are the two reasons in this class, at least at this point: square root function and dividing by a variable. So here we're going to set the denominator to 0 and then make sure, and then exclude those values of x. So this factors, so that's why I had that extra factoring assignment in MATLAB. I don't think, for this class, I don't think it was due until the next test. But if you got it done, that's great. Just a review on factoring. You got the first term is x times x gives you x squared. And then you have a minus sign here means you're going to need opposite signs to get a negative sign on the last term. And then what are the factors of negative 21 that add up to negative 4? And maybe, hopefully you guys get that. We're looking for the factors. I'm writing it down for you. Negative 21 that add to negative 4. And they are negative 7 times 3 gives you negative 21, but negative 7 plus 3 gives you negative 4. So we need negative 7 and 3. And that's just a quick review on factoring when you don't have a number out here. So we can find the factors of C that add up to B. Using the quadratic formula is just going to take too much time, but it's a simple factoring problem. So I know you guys are looking at me like you know this. So I'm going to use this recording for my other classes. So. Okay. All right. So we set each factor then to 0. So x plus 3 equals 0. So subtract 3. X equals negative 3 would make the denominator 0. And set x minus 7 to 0. Add the 7. X equals 7. So we need to exclude negative 3 and 7. So I'm going to show you, and maybe you don't need these baby steps, but if you're going to exclude these two numbers and you want to write it in interval notation, it's going to be these three areas. Negative infinity to negative 3. So it's negative infinity to negative 3. And we use a regular parenthesis because we're excluding the negative 3. Union negative 3 to 7. Union 7 to infinity. And that's the domain for this function. We just excluded the values that would make the denominator 0. Notice we didn't solve this equation or anything, it asked for the domain. Okay, and the next problem, we've got a fraction within a fraction, and that's not considered simplified, so I can show you how to simplify it, but we're going to just start with leaving it as a fraction within a fraction. Look, we've got a denominator here, x. So guess what? X can't be 0. So in the unsimplified denominator, we can see we're dividing by x, so we can't let x be 0. And then we can't let this whole denominator be 0. So 2 over x minus 4 can't be 0. Or I could set it to 0 and then say that's the number it can't be at the end. But we just solve it the same way. We're going to add 4 to both sides. 2x can't be 4 over 1. And I'm going to cross multiply. You don't have to do it this way. You could multiply through by x and also get the same result. But you could, if you have a single fraction equals a single fraction, you can cross multiply. Let me write that up here. A over B equals C over D is A times D equals B times C. This is cross multiplying, and it's only when you have a single fraction equals a single fraction. Then you can do this times this equals this times that. That's the only time you can cross multiply. So we get, I'm going to do the 4x first. 4x equals 2. And then we're going to divide by 4. So x is a half. So we're going to exclude a half and 0. So x can't be. So we could draw the picture again, but the smallest number is 0 and the next number is a half. So there's going to be 3 areas. Those are open circles. So the domain is going to be minus infinity to 0, union with 0 to a half, union with a half to infinity. Oops. And I went off the page. So. Oh, there you are. Okay. If you want to. All right. Okay, so the other thing we could do is I could simplify that denominator first. And there's many ways to simplify that denominator. But we do have to first make sure we look and see that there's an inside denominator. We do have to note that x can't be 0. If you were going to simplify j of x, 3 over 2 over x minus 4. I found that the easiest way to do that is to multiply. You want to get rid of the x in the denominator here. So we want to multiply the denominator by x. But if you multiply the denominator by x, you got to multiply the numerator by x too. So you're just changing the look of the fraction and simplifying it. You have to put parentheses there. So you're going to distribute this x. X times 2x, 2 over x is 2. well, you know, you're going to get 3x, and you're going to have x times 2 over x minus 4 times x, 4x. And I wouldn't, and then you cancel these. I wouldn't, I know they don't show this step, but maybe that'll help you. Equals 3x over 2 minus 4x. Okay, so you do need to note that x can't be 0 because of the unsimplified fraction within a fraction. And now you can set your simplified denominator to 0. And 2 minus 4x can't be 0. So we can add the 4x. We get 2 can't be 4x. And x can't be, we divide by 4. X can't be a half. And that was a little simpler than the cross multiplying stuff, but this is how you simplify a fraction within a fraction. I just took this denominator and I wanted to multiply through, you know, I multiplied through by x over 1. And you have to distribute that to each term here. There's parentheses around this. That's the simplest way. You can also get a common denominator in one of my worksheets. Did you have a question?
Yeah, I was going to ask, do you prefer which way, or you can do either way?
Oh, it's fine. You can do it this way. Most people like this way, but you can also get a common denominator in the bottom. Do you want me to show that? Oh, you got it. You can get a common denominator down here and then flip the second fraction, you're going to get the same thing. So you don't have to do it this way. This is just, in fact, I use the common denominator method on the solution to 1.7 homework worksheet. But, so, any questions about that? Does anybody want to see the common denominator way? No, you guys get it. Okay. You don't have to be shy. All right. All right, so that's, you guys can now, after I've lectured on this part, you can do the domain worksheet at home. you know everything to do that domain quiz that's out there. Because that's what it's asking. And these are your algebraic steps. You know, if you get one like this, you don't have to show any steps. That one. Okay. All right. All right. Okay, now we're going to talk about combining functions. So if we've got two functions, we have function notation. If we want to add two functions, how are we going to do that with function notation? This is the notation, and this just means f of x plus g of x. This is just function notation for adding two functions. It is nothing more than that, but it does not mean that you multiply through by x. A lot of people keep thinking that. And this is just function notation for taking the difference of two functions. So it actually means f of x minus g of x. And then this is function notation for multiplying two functions. So this means f of x times g of x. And sometimes we'll use, Excel uses an asterisk for times, so sometimes we use an asterisk for times. You'll see it either way, a little dot or an asterisk, but we usually use the dot, and you don't usually see the x for the time sign in algebra because we're using x's for variables. We don't want an x there. Okay, and then the quotient. This is just the notation for dividing two functions, and it just means f of x divided by g of x. But we have a denominator, so we need to make sure that g of x is not equal to 0. We got some x's in that denominator, so we just need to make sure it's not equal to 0. So you'll note that. So here's some examples. find f plus g of x. Here's f of x is 3x plus 1, and g of x is x squared plus x minus 2. So this is just going to be 3x plus 1 plus x squared plus x minus 2. So what are we going to do? We're just going to combine our like terms. So x squared is our highest power term, and there's no other squareds. And then the 3x plus the 1x, there's an understood 1 here, okay, is 4x, so that's plus 4x. And then 1 minus 2 is minus 1. And this is your answer to f plus g of x. And then determine the domain. Well, in the original function, there was no restrictions of our domain, minus infinity to infinity on both. And here we don't have any reason to restrict the domain. We're not dividing by any variables, and we're not taking any square roots. So the domain is minus infinity to infinity. And then find f minus g of x. And that is f of x minus g of x. And so f of x is 3x plus 1 minus, and then we do need to make sure we distribute this minus sign. So we're going to distribute the minus sign, and it's going to end up changing the sign of every term. So it's going to be 3x plus 1 minus x squared. Inside here it was a positive x squared, now it's negative. Minus x, it was positive in here, now it's negative. And negative, minus a negative is plus. So it was negative, now it's positive. The negative sign outside the parentheses changed the sign of every term. Now we're going to combine our like terms, x squared, and then it's 3x minus 1x is plus 2x, and 1 plus 2 is 3. And there's no reason to restrict the domain. We've got all real numbers here. There was no restrictions on these, and there's none on what we got. So it's all real numbers. Yes?
Carry the negative one with the x squared?
What, Carrie, did I mess up?
No, I'm just asking. It says negative x squared, but then at the bottom it says just x squared.
Oh, I messed up. Okay. Negative x squared, yes. Oh, and I could be looking at my answers so I don't do stuff like that. So, yes, I messed up. That's what happens when you're standing in front of class. All right, any other questions? Okay. Okay, find f times g of x. This means f times g of x. And remember, our f of x was 2x minus 1. And our g of x is x squared plus 3x minus 6. Okay. Oh, all right, thank you. Okay, so we're just going to multiply that. Well, we can either, did I write that down wrong?
That's not the equation that I have.
No, that is not. Oh, I was looking down at the example at the bottom of the page. Okay. Okay, well, let's try this again. All right. It's f of x was 3x plus 1, and g of x was x squared plus x minus 2. Okay. So, f times g of x will be f of x times g of x is 3x plus 1 times x squared plus x minus 2. Okay, so you can either solve this by distributing, so each 3x would have to be multiplied by every term over here, and the 1 would have to multiply it, and then you'd have to add them all together. Well, I like to actually write it down as x squared plus x minus 2 and 3x plus 1 and do long multiplication. So I'm going to do 1 times each of these things. 1 times negative 2, 1 times x is positive x, 1 times x squared is positive x squared. Then I'm going to do 3x times negative 2 is minus 6x, and I want to write it under its like term because I'm going to add. So I'm multiplying, and then I'll add my like terms. But I probably should have written add right there because it's going to get in my way. Okay, so 3x times minus 2, I got that. 3x times x is plus 3x squared, and 3x times x squared is 3x cubed. See, it got in my way. So we add those now. 3x cubed plus 4x squared minus 5x minus 2. Okay, and that's our answer to f times g of x. And you could have got it by distributing and writing it all out long and combining like terms. I kind of like to put my like terms underneath each other. And so, is there any restrictions on this domain? Well, there were no restrictions up here or here. And when we multiply, we don't have any x's in any denominators, so there's no restrictions. So the domain is minus infinity to infinity. Okay? All right. And then the last example here, these simple examples with, I have f of x and g of x written down, is when we want f divided by g of x is f of x divided by g of x is going to be 3x plus 1 divided by x squared plus x minus 2. So the denominator, to see, this is the answer, because when you factor this, nothing cancels. So this is the answer, but we got to restrict the domain because we're dividing by this. So we make sure the denominator can't be 0. So we're going to set the denominator to 0 and exclude those values. So this factors into x and x. The negative sign means plus, minus. So we need a positive 1x in the middle, so we have a plus 2 and a minus 1. And that works. You can check your inner terms. You can check, FOIL it out, make sure it works. So either x plus 2 equals 0 or x minus 1 equals 0. So x is negative 2 or x is 1. I just subtract 2 from both sides, or I add 1 to both sides. So I need to exclude those values. I can't write today. All right, so to write that in interval notation, if you need to do it, you can draw a number line, put the smaller number on the left, the bigger number on the right, draw open circles. You're going to have 3 areas, 3 intervals. You're going to have minus infinity to minus 2, union with minus 2 to 1, union with 1 to infinity. 1, 2, 3 intervals. And that's our domain. The only one that had a domain other than minus infinity to infinity was this last one where we're dividing by g of x, because we have variables in the denominator. Okay, so we're gonna, any questions? We're gonna keep going. It's such a small class. 8 of you here. All right, so here's our functions. And now we're taking square roots, so we will be restricting the domain. But let's find f plus g of x, and then find its domain. F plus g of x equals f of x plus g of x, and that just equals the square root of x plus 1 plus the square root of x minus 4. Now, so we can't combine these. Just a reminder about like radicals. If you had 2 square root of 7x plus 3 square root of 7x, then you have like radicals. You have square roots and you have the same radicands. Those, they have to be the same root and the same thing underneath the radical sign. And then they're like radicals, and you can combine those like variables. That would be 2 plus 3 is 5 square root of 7x. But because these are different, you can't combine these. So this is f plus g of x. That's f plus g of x. Now we need to find the domain. So for this function, we need to make sure that x plus 1 is greater than or equal to 0. And we subtract 1, we get x greater than or equal to negative 1. And that's negative 1 up. That's what we're talking about. But this part, x minus 4, means that x minus 4 has to be greater than or equal to 0. We add the 4. X has to be greater than or equal to 4. So 0, 1, 2, 3, 4. So we've got 4 and up. So is the domain this or that one? Well, what happens if we put in 0 over here in this one? If you put in 0, you're going to get square root of negative 4, and that's not a real number. So we have to take the intersection. That's this sign of these two. Where they overlap is just this. So our domain square bracket 4 to infinity. So, this original domain was 4 to infinity, and this one was -1 to infinity. And we had to take the intersection of those. Make sure we can't have it. If we checked, you can just test a point. If you're not sure, we put in 0, it works here but not here. So we had to have it be 4 or above. So I wrote down, for this, I wrote on my fill-in notes, you have to make sure there were no square roots of negative numbers. So when you're trying to figure out which one is it, you had to, if you used 3 in here, you got -1. You're taking the square root of -1. Use 3.5, you're taking the square root of -1/2. So you had to use 4. If you can't remember that it's an intersection, you have to try the numbers. Just try the numbers in each square root sign and make sure you don't get any negative square roots of negative numbers. All right, that's combining functions and some finding domains with square roots and fractions. But so now we have a new definition. The composite of the function f with g is denoted by f, like a degree symbol, g, f composite g. It's also written as f composite g of x. And sometimes we just say fog. It looks like fog. Sometimes we'll say fog. And what that means is that it's f of g of x. Okay? So, this is called a composite function, and the domain of the composite function f composite g is the set of all x such that x is in the domain of g of x and g of x is in the domain of f of x. And it says to see an illustration, I'll just draw it. So we got x going into g of x. I'll just put g. And then we got g of x coming out, and that's going into f. And then we have f of g of x coming out. And that's f composite g of x. So that's why we had to make sure x was in the domain of g, and what comes out of g had to be in the domain of f. That's where they got that. Okay, so we're going to practice finding these composite functions. So if f of x is 2x minus 1, and g of x is x squared plus 3x minus 6. Now, does that look familiar? From up above, when I tried to use it. Okay, so just rewrite, what does f composite g of x mean? It means f of g of x. So replace g of x with what it is. Leave a big space. And we're going to put g of x in there. X squared plus 3x minus 6. Okay, well what does that mean? F of all of this means everywhere you have an x and f of x. So you're going to rewrite it and leave space for that whole thing. This is my x. It's 2x minus 1. So this is the only place I had an x. We're going to replace it with x squared plus 3x minus 6. And then we're going to distribute. So equals 2x squared plus 6x minus 12 minus 1. Combine our like terms. 2x squared plus 6x minus 13. And that's our answer to F composite G of X. Okay, so you're going to have to practice these.
I got a question.
Yeah.
Why don't you put 3 out instead of 2?
Why didn't I do what?
Put 3 out.
Did I make a mistake or what? Why did it have a 2?
Yeah.
Because the 2 was here. 2x minus 1. This is 2x minus 1. So this is f of x. F of something means everywhere you have an x and f of x, you replace it with that something.
Okay.
That's where I got the 2. Okay? Now that's a good question. You gotta see where I'm coming from. And you gotta practice this function notation if you struggle with it. You gotta practice it. So that's why I did it in different color too. Okay? Now, and you notice you don't get just a number, you get an expression. Now don't magically set that to 0 and solve for x. It doesn't work that way. Alright, we're going to do the next one. What is g of f of x? G composite f of x. We just did it, isn't it going to be the same thing? No. Okay, so you need to write what it means. It's g of f of x. And it's different because now f of x is our inner function. We would switch these two. Okay, but I'm not going to bother drawing the picture. So is g of f of x. So we're going to replace f of x with what it is. So f of x is 2x minus 1. And put that right in there. Now you got g of 2x minus 1. Well, that was from section 1.1 or 1.2 or something. You're going to replace, it's probably 1.1 that we didn't even cover. But you're supposed to read it. Watch tape. So everywhere you have a 2x, everywhere you have an x in g of x, you replace it with 2x minus 1. Well, I'm going to do that in 2 steps. I'm going to write down what g of x is, but leave enough space. I have x squared plus 3 times x minus 6. So everywhere I have an x in the g of x, right here, I'm going to, I left a big space for it so I can put it in here. Instead of x, we're replacing it with 2x minus 1. Okay? Now, if you need to go off to the side and write 2x minus 1 squared, or 2x minus 1 times 2x minus 1, and figure out that that is 4x squared minus 2x minus 2x. It's the outer term, the inner terms, and then the last term. Combine those, and you get 4x squared minus 4x plus 1. Oh, okay. And then distribute the 3 plus 6x minus 3, and then subtract the 6. So if you already know what this is, you can write it down. Just don't forget your middle term. I just spoiled it up there for you. So now we're just going to combine our like terms. And I guess I'm going to write the answer for you. Let's see. So 4x squared has no other like terms. Then a minus 4x plus a 6x is a plus 2x. And a 1 minus 3 is minus 2, minus 6 is minus 8. And you can use your calculator to help you if you need to on those. That's your answer, and it's not the same. It's the same as I filled in notes. But I don't even know if I have those posted for you. Do I?
Yeah, you do.
Okay. That's the same as I filled in notes, so it means I didn't make a stupid mistake up here. But all right. But it's not the same as that because going the other way, switching F and G around make it different. Okay, and then the last example is what if we ask you to find F composite G of a number? Well, this means F of G of 2. So you can find G of 2 first if you want. Everywhere you have an x in G of x, you're going to replace it with 2. That's what that means. So you have 2 squared plus 3 times 2 minus 6. That's 4 plus 6 minus 6 equals 4. That's G of 2. Well, now we have to find F of G of 2. Well, G of 2 is 4, so F of 4. F of 4 is everywhere in F of x that you have an x, you're going to replace it with 4. 2 times 4 minus 1. 8 minus 1 is 7. Okay? Or, since we had already found the general F composite G of x, we could have just replaced x over here with 2. This is actually easier if you don't have to find this. But if we just if we want to replace x with 2, it's 2 times 2 squared plus 6 times 2 minus 13. That's 2 times 4 plus 12 minus 13. 8 minus 1 is 7. So we could have got the same answer, 7. So since we'd already figured F of G of x out. But it's actually easier if you haven't figured F of G of x out to just start to find G of 2. And then plug in 4 for G of 2, find F of 4. And that's easier math than doing all this first. Any questions? Those are composite functions. Okay. All right. Is this all review for you guys still? Okay, I thought you kind of looked bored. It's okay. You're paying attention though. That's good. All right, and then, but you'll do great going right into 1720. Are you signed up for 1720 now? Yeah.
have it like right after this class.
Yeah. We get done right before spring break in this class, and those of you that are signed up for 720, then start class, I think, the Monday after spring break, and do 1720. 1720 is a much harder class than this one. So if you work as hard as you are in this one, keeping up with the work and everything, you'll do fine. You got to memorize stuff. Yes.
Can we take a quick break?
Sure, we can. How long? I've been going and out to get that ready. As soon as possible, so things can pile up. All right, so there's just a typo in here. I forgot to fix it when I fixed it. No. This is just 1 over x. That little prime mark or the little apostrophe doesn't really belong there. If you were in calculus, it might mean derivative. No, it's just 1 over x. So here, now we've got two functions, and they have variables in the denominator. So we want to find f of g of x. That's what this means, f of g of x. F composite g of x. That's what that little degree symbol there means. It's like a degree symbol. So everywhere, so we're going to replace g of x with what it is. G of x is 1 over x. All right, I didn't need that big a space, did I? Now what does that mean? Everywhere we have an x in f of x, so we're going to write out 5 over x plus 4. That's f of x with a big parenthesis for our x. And we're going to put our 1 over x in there. That's what it means. F of 1 over x means everywhere you have an x, you replace it with 1 over x there. Okay, now we're going to simplify this. So the easiest way to simplify this is you can't have a fraction is not considered simplified if it has a fraction within a fraction. So we want to get rid of this denominator of x. So if we multiply by x over 1, that will get rid of that x here. And then we need to, if we're going to multiply the denominator by x, we're multiplying the numerator by x too. And so you get 5x, and x over 1 times 1 over x is 1, and x times 4 is 4x. And this is your simplified f composite g of x. Let's see, did I get it out? Let's see if I printed. Oh, here they are. So in D2L and maybe in Shobi, I don't know, Shobi, there's some additional notes for 1.7. So we're going to find this domain. And you can find it two ways. This is additional notes for 1.7. We'll just talk about that. So you can look at the inner function and find its restrictions. Look at the outer function and find its restrictions. Because the inner function is going into the outer function, remember the picture, if we're doing f composite g is f of g of x. And the picture was that we had x going into the inner function, g, And then we have g of x going into the outer function, f. And then we have f composite g coming out. So that's why you look at the inner function and find its restrictions. And if g is second here, it's the inner function. So that would be g of x. Then you look at the outer function, f composite g, f is the outer function. And then because the outer function, f, doesn't have x going into it, it has g of x going into it. So you have to set the restrictions. You have to find where the inner function equals the outer function's restrictions, where g of x equals f's restrictions. And then the domain will be taken from step 1 and 3. The domain is taken from, you gotta restrict the domain to what? X going into g of x and g of x going into f. So this is one way to do it. Or, especially if it's a fraction like this, we can look at the unsimplified function and find the inner function's restrictions. That would be for f composite g, that's g. That's its restrictions. And then you can look at the simplified function and find its restriction, and then use these restrictions to write your domain in interval notation. So I find that it's a little easier to do this than to do all of this. So I can say you can do either one. I added this, I changed this semester to add this to the extra notes. It's just easier to do this, so we'll just do this. So look back at our function. Before we simplified it, it's this form. There's the inner function, 1 over x. What do we have to make sure x cannot equal, can't divide by 0. If x is 0, you're going to be dividing by 0. And this is the unsimplified function. So, because of this, let me use green. X can't be 0. So this x can't be 0. And that's really the restrictions of g of x, the inner function. Now, the second one, look at the simplified function. Because this has a part that's in the denominator, we can't let the denominator be 0, so we set, for this kind of function, we set the simplified denominator equal to 0. So 1 plus 4x equals 0. 4x equals -1, and we divide by 4. X can't be a negative of 4. We can change those to a not sign. Okay, so step 3 is actually, I'm doing it the shortcut way. Okay. So, is that we can't let, x can't be negative a fourth, and x can't be 0. So if we write that in interval notation, it's minus infinity to minus a fourth, regular parenthesis to exclude the minus a fourth, minus a fourth to 0, parenthesis 0 to infinity. And that's the domain. In the filled-in notes, I followed the 4 steps. And it took a lot more space and it was more complicated. So I think this simplifies it. But you do have to make sure you look at the unsimplified function. Okay. The next example, any questions? All right. Okay, and now you got another example. F of x is square root of x, and g of x equals x minus 3. Find f composite g of x. So we're going to find f of g of x. And I could ask for g composite f, but I usually don't. Usually don't switch around that much. If you can find one, you can find the other. So replace g of x with what it is. F of x minus 3. G of x is x minus 3. Now, everywhere you have an x, you're going to replace that x minus 3. All right, so doing these steps, we're looking at the inner function restriction. And I said that. The inner functions restrictions. G of x is equal to x minus 3. Are there any restrictions? It's x minus 3. It's just a line. There's no restrictions. So there's none. Step 2, look. Now we're not going to set the simplified denominator to 0. We got a square root. So we got to make sure that you can't have a negative number underneath the square root. So we have to make sure x minus 3 is greater than or equal to 0. You can't have negative numbers under a square root. So we add 3. So x has to be greater than or equal to 3. And so step 3, the domain will be this restriction and this one. That one, there's none. So this is the domain. And we write it in interval notation. 3 to infinity. Okay, any questions? Does that make sense? All right, the next one, we're going to find f composite g of x. That's f of g of x, f of square root of 1 minus x. So everywhere in f, you have an x squared plus a 4. Everywhere you have an x, you're going to replace it with the square root of 1 minus x. When you square a square root, those undo each other and you're left with 1 minus x plus 4. So you get negative x plus 5. Your simplified f composite g is that. And you might be tempted to say there's no restrictions to the domain, but there are. Because we have to look at the unsimplified function. So step 1, we look at the unsimplified function or the inner function's restrictions. It's a square root, so you have to make sure that the radicand, or what's underneath the radical sign, is greater or equal to 0. So we're going to subtract 1, negative x greater or equal to negative 1, and then we're going to divide through by a negative 1. When you divide or multiply by a negative, you got to switch the sign. So negative x times negative 1, or divided by negative 1, less than or equal to -1 times -1 is x less than or equal to 1. This is the only time you switch an inequality is when you divide or multiply by a negative number. So I'll just write this as a note, switch inequality sign when you divide or multiply by a negative number. Okay? So, if you're not sure, you can put a simple example. Like, 1 is less than 10. What happens if I multiply through by -1? -1 and -10, which way does the inequality go? Greater than. We had to switch it. -1. So 1 is less than 10, but -1 is greater than, I multiplied through by a -1. To show you with just numbers, if you forget the rules, you can just take some numbers and try it. Okay? That's what I did all the time. Okay, so there's our domain. There's inner functions restrictions. Step 2, the simplified restrictions, and there's none. So step 3, the domain is based on number 1 here, 1 to infinity. Wait a minute, I did it wrong.
Yeah. Just negative infinity.
Negative infinity to 1. It was a less than or equal sign. So, and if you have trouble with that, you can just draw a picture. 1 yeah. Okay. Is that it? Oh, just one more page on this section. So what if you're given like something and we want to express this as a composition of two functions? So we want to write h of x so that it's f of x composition of g of x, or f or f composite g. So what functions could you pick? Well, you want to make your g, if you write it this way, make your g your inner function. Can you see an inner function you could pick off from this thing? G of x is the inner function. Should be should be this, x squared plus 1. And then let's try it. F of x should be the outer function. F of x should be the cube root of x. And then try it. F of g of x would be f of x squared plus 1 would be the cube root of x squared plus 1. And that works. So this is your inner function and your outer function. So this is the answer. As long as you're doing f composite g. Alright, and if you want to do this one, we're going to do f composite g again. So g of x is going to be the inner function. That's going to be 3x plus 7. What's inside the absolute value sign. Then f of x is going to be the absolute value x. And then you check it by doing f of g of x, f of 3x plus 7. Then you replace, everywhere you have an x, replace it with 3x plus 7. Okay? And that worked. So, inner function, outer function. So look for an inner function and outer function. And that's section 1.7. Any questions?